This is lesson 4-1, Congruence. Please put your name, date, and period. Your objectives today. Students will be able to identify a sequence of rigid motions to justify the congruence of two figures. Justify the congruence. Students will demonstrate that two figures are congruent by using one or many, one or more rigid motions to map one onto the other. So what that means is if you have a shape, like let's say you have this triangle and it moved to over here as a rigid motion, you could map this triangle onto this other triangle. And it looks like it would be a reflection and a translation. Your vocabulary or your vocabulario is congruence, transformation, or transformación de congruencia, and congruent, congruente. Concept, congruence. Figures that have the same size and shape are said to be congruent. So they have the same size and the same shape. Two figures are congruent if there is a rigid motion that maps one figure to the other. Right? So if we do a rigid motion like a translation and a rotation, and that maps the other figure onto the new figure, then they are congruent. A rigid motion is sometimes called a congruence transformation because it maps a figure to a congruent figure. We use this symbol to show that two figures are congruent. So that symbol means congruent. So the way we read this is since the reflection, and I had told another student this, that the big R means reflection, whereas the little r shows a rotation. Since the reflection over the line M, and you can see the line M is right here, of triangle ABC is equal to triangle DEF, then triangle ABC is congruent to triangle DEF. Triangle ABC is congruent to triangle DEF. And you can see that the angles are congruent and the measures of the sides are congruent. Everything is the same. Same shape and size. Example 1. A 90-degree rotation about the origin maps triangle PQR to triangle LMN. As I'm reading this, make sure that you are reading along with me. Your eyes are following along on your paper with these words so that you know how to read the math symbols and you know how to say them. And the question is, are the triangles congruent? Well, yes, because that's the definition of congruency. The definition of congruent is a figure can be mapped onto another figure. Right? So if we had the triangle PQR and we rotated it about the origin and it ended up over here as the same triangle, That's not quite 90 degrees, but you get the idea. If we rotated it 90 degrees, something like that, and we got LMN, the two triangles would line up to each other, then they are congruent. So basically, just by the definition of congruent, they are congruent. Because a 90-degree rotation is a rigid motion. So that's another reason. 90-degree rotation doesn't change shape or size. So as many ways as you can describe this, that answers or explains why the two triangles are congruent. When you turn your page over, we have example 2, verify congruence. Given triangle XYZ is congruent to triangle ABC, what composition of rigid motions maps triangle XYZ to triangle ABC? So what we're going to do here is we're going to move each point. If you can see this, it looks like a rotation and a translation. For me, it's easier to rotate it about the same point. So I'm going to move Z 3 over because it'll correspond to C, and then we can spin it around point C. I'm also going to move X 3 to the right and Y 3 to the right. And I did that so that Z would align with C. So our first step is we translate right 3. So that gives us points here, here, and here when we move every point over to the right 3, and we now have this red triangle. If I rotate this triangle, it will line up onto AB, and it looks like a 180-degree rotation. I think I'll give you guys some tracing paper, or if I haven't already passed it out, I will pass it out so that you can trace triangle, the new triangle, or even the original XYZ, move it to the right 3, and then spin it and see if you can get it to line up with triangle ABC. So the second step would be to rotate 180 degrees. Okay, and to write that as a composition, we would put T parentheses 3 comma 0, or sometimes they use these kind of inequality brackets, and then we write it backwards because we did the translation first, and then the rotate we use the little r, 180 degrees. And we do that to triangle XYZ to get triangle ABC. So that's how we write it in math symbols for the composition of rigid motions. So composition of rigid motions, that is this math sentence. Example 3. Identify congruent figures. Given triangle ABC, triangle EFG, and triangle JKL, which triangles are congruent? So we kind of need to see where they map onto. And you can measure, like you could trace ABC, and you can try to take that tracing and put it on top of another one. And you may have to flip your tracing paper over to reflect it, right? Like if you flipped your tracing paper over, then it would show a reflection. So see if you can find which two are congruent using your tracing paper. to me, just like by eyeballing it, it looks like ABC and JKL are congruent. So triangle ABC, and we use this symbol to show congruent. Is congruent to triangle JKL. And I'll come around and check your tracing paper to see if you are getting this to line up. But to me, it looks like you could just translate it down. So translate C down to here, which is down 3, translate B to here, and A to here. And then I could reflect it over this line, which is the line, I'll call it M, line M is X equals -4. So it, to me, looks like those two are the triangles that are congruent. And you should write this down in your notes as well, even if you use the tracing paper to prove it. And we would write that composition as we translated it down, not left or right, so 0. We translated it down 3, and we reflected it over line M. And we did that to triangle ABC to get triangle JKL. Okay, there's another example 3. Another try it. So we want you to see which ones of these, use your tracing paper, are congruent, if any of them. To me, it looks like it could possibly be A, B, C, D, E. Might be congruent, so this is a question for me, to WX VWX YZ. But to answer the original question, I would say no, because it does not appear to me that ABCDE is congruent to JKLMN. And you can test that with your tracing paper. Okay.